All right, so we've got one more example for using the first derivative to find maximums and minimums that I want to do with this set of lectures. And so we're going to take f of x to be x minus 2 times the sine of x. And we're going to take this for x's between negative pi over 2 and 2 pi. Now, this is a closed and bounded interval. So we are guaranteed that we can find relative maximums and minimums, but we're not going to take advantage of that in this case. I want to go through some of the process for finding relative maximums and minimums so that you can see how that's going to work with our trigonometric functions. So we're not going to be looking for just the absolute max and min. We're going to look for any relative max or min values. Actually, let's do this between 0 and 3 pi. Sorry, between negative pi over 2 and 3 pi. Those relative max and min values can only occur at, of course, critical values of f prime. So better find the derivative here. F prime of x. The derivative of x is just 1. The derivative of 2 sine x is going to be 2 times the cosine of x. Of course, this is not going to have any undefined values. And so we're going to go ahead and set that equal to 0. If we were looking at something like the tangent of x, or secant of x, cosecant of x, one of those reciprocal functions, of course we would have a denominator that might turn out to be 0, and we'd have to be a little bit more careful to make sure that we find these undefined values. But that's not going to happen here for us. We just need to know where this guy is equal to 0. 1 minus 2 cosine x equals 0. We can do a little bit of algebra to discover that cosine of x should be equal to 1/2. Cosine, of course, is the x value on our unit circle, and so we want that x on the unit circle. We want the angle that's going to give us a y value of 1/2. What are those angles? Well, we have theta equals pi over 3 here. We have theta equals negative pi over 3. But those, again, those are just reference angles. We are measuring them from the x-axis. These are not the only solutions that we could have in our interval from negative pi over 2 to 3 pi. Certainly negative pi over 2 is down here, but if we go from that to 3 pi, that's going to take us all the way back around to the, from negative pi over 2 to 0 to pi to 2 pi to 3 pi. We're going to pick up several more solutions here. And so we're going to add we're going to add 2 pi to each of these, and then keep the values that are between negative pi over 2 and 3 pi. So we take this negative pi over 3, We're going to add 2 pi. That's going to take us all the way around the circle to this angle again. We get a common denominator. That's negative pi over 3 plus 6 pi over 3 makes 5 pi over 3. If we add 2 more pi, again, we're going to get 5 pi over 3 plus another 6 pi over 3 makes 11 pi over 3. But that's way more than 3 pi. So we want to stop at, say, 9 pi over 3 would be 3 pi. Then we're going to take our pi over 3, the positive pi over 3, and we're going to add 2 pi to that. That's pi over 3 plus 6 pi over 3 makes 7 pi over 3. That's less than 3 pi, and so we'll keep going. 7 pi over 3 plus another 2 pi is 7 pi over 3 plus 6 pi over 3 is 13 pi over 3, but that is, again, way more than 3 pi. So we won't keep that one. Our critical values are negative pi over 3, pi over 3, and then we are going to keep the 5 and 7 pi's over 3 to form our intervals. Go on to our next page, and again we'll just summarize what we have. F of x, x minus 2 sine x. F prime of x is 1 minus 2 cosine of x, and our critical values are negative pi over 3, pi over 3, 5 pi over 3, and 7 pi over 3. Divide up our number line. And our number line, I'm putting little square brackets at each end because we have a closed and bounded interval. Our number line is not going out towards positive and negative infinity. We are restricting ourselves to this interval from negative pi over 2 to 3 pi. Negative pi over 3, and then 0, and then pi over 3, 5 pi over 3, and 7 pi over 3. This is going to give us all of these intervals that we need to work with, and we can start to choose our test values. We need a number over in this little segment under the number line. I'm going to go ahead and pick negative pi over 2. A number between negative pi over 3 and pi over 3 would be 0. A number between, say, pi over 3 and 5 pi over 3, I'll pick 2 pi over 3. Between 5 pi over 3 and 7 pi over 3, I'm going to pick 6 pi over 3, which is better known as 2 pi. And between 7 pi over 3 and 3 pi, I'm going to pick 3 pi. I am cheating just a tiny little bit here in choosing these endpoints, and I'm really doing that because it's going to simplify some of our calculations. If we want to be super duper honest about it, we're not allowed to pick those, but we also know that these functions are defined for more than just the interval from negative pi over 2 to 3 pi. So, kind of being a little sneaky with these first and last critical test values. So we're going to plug each of these into f prime, and f prime of negative pi over 2 is 1 minus 2 cosine of negative pi over 2. Now cosine of negative pi over 2 is 0, and so all this stuff adds up to 1. We go back to our chart. We have that the derivative is positive for one value in this segment. It's going to stay positive. F prime of 0, 1 minus 2 cosine of 0 is 1 minus 2 is negative 1. That's less than 0. We plugged in 0 to our derivative, and we got a negative number, and so we will get more negative values as we plug more values from this interval. Negative for one value means negative for all of them. We continue. F prime of 2 pi over 3 is 1 minus 2 cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative a half. Multiply that by negative 2, and we get 1 plus 1 is 2, which is positive. So at 2 pi over 3, our derivative is positive, and we've said many times so far that the derivative is going to stay positive throughout that segment, that interval on the number line. F prime of 6 pi over 3 was our next critical value. F prime of 2 pi is 1 minus 2 cosine of 2 pi. Cosine of 2 pi is 1. Multiply that by 2. We get 1 minus 2 is negative 1, which is still less than 0. And then F prime of, what was our last one? 3 pi is 1 minus 2 cosine of 3 pi. Cosine of 3 pi is negative 1. Multiply that by negative 2. We get 1 plus 2 is 3, and that's positive. I'm going to take these last two function evaluations and go ahead and add those into our chart. And then look for sign changes. We have a sign change from positive to negative at negative pi over 3. And so there is a relative minimum, relative maximum. It's about lunchtime for me, and I'm fixing to take a little break. A relative maximum at x equals negative pi over 3, and our max value, f of negative pi over 3 is negative pi over 3 minus 2 sine of pi over 3. And I looked that up on my calculator and was about 0.685. We continue. We see another sign change here at x equals pi over 3. This time from negative to positive. The first derivative test tells us that we have a relative minimum at x equals pi over 3. And our minimum value is f of pi over 3. That's pi over 3 minus 2 sine of pi over 3. And according to my handy dandy little calculator, that is approximately negative 0.685. Again, I'm sorry for kind of running off the bottom of the screen. Y'all just have to tell me when I do that, and I'll move the paper. Here at 5 pi over 3, we have a sign change again. This time from positive to negative, and so we have a relative max at x equals 5 pi over 3. And that maximum value is f of 5 pi over 3. It's 5 pi over 3 minus 2 sine of 5 pi over 3, which turns out to be about 6.97. And then finally, we have a little relative minimum. The sign changes this time negative on the left side to positive on the right side. At x equals 7 pi over 3. This time from negative to positive. And so there is a relative minimum. F of 7 pi over 3 is 7 pi over 3 minus 2 sine of 7 pi over 3 is approximately 5.5, about 5.6. In reality, all of these have exact values. The sine of pi over 3 is the square root of 3 over 2. And if we add these guys up, we're going to get negative pi over 3. What is this going to be? Minus 2 square root of 3 over 2 is negative pi over 3 minus the square root of 3. Here, why is that negative? Oh, because this should be negative, and that's going to be plus. This is going to be the square root of 3 minus pi over 3. Negative square root of 3 plus pi over 3. This guy is going to be 5 pi over 3 minus 2. Let me go around in the circle a little bit. That's going to make plus the square root of 3, and this should be 7 pi over 3 minus the square root of 3. In terms of something like WebAssign, they're generally going to be looking for these exact values. You do not have to come up with the decimal approximations, although that would help you in drawing the graph. But the answers that WebAssign is going to be generally looking for, and the answers that I usually prefer are these exact values in terms of these pi over 3s and square roots of 3s, either added, subtracted, whatever the function tells you to do. But just be aware that converting all this stuff to decimal is not the typical practice. It is not the best way to do it. It just happened to be what my calculator over here was giving me as the answers. So, our next thing is going to be to look at some applications of these increasing and decreasing functions. We're also going to look at, we've gotten all of this information so far from the first derivative, but we'd also like to see what kind of information we can get out of the second derivative. And so that's going to be our next video. That's also going to give us another test for maximums and minimums, for classifying these critical values. That's going to be very useful to us, and it's also going to help simplify some of this plugging in quite so many values. So we'll pick that up in the next lecture. Thank you.